Okay, so tomorrow we have a quiz over Module 6 in Unit 1, which is all about special segments and triangles. And I'm just going to let you go ahead and come along with me while I make the key for the quiz review that I gave you today in class. Keep in mind that I might go a little faster than I would in class, and that's because this is a video. You can stop it and rewind and listen again as many times as you would like. Or pause it and think about what I'm talking about. Okay, so first of all, use the diagram shown and the given information to decide in each case, so these are 5 separate cases, whether AD is a perpendicular bisector, an angle bisector, a median, or an altitude. I think what I'm going to do is I'm going to draw that information myself on my own triangle to see what they're talking about. So we've got ABC, and we're talking about segment AD. And the first thing says DB is congruent to DC. Okay, if you watch the other video, you know that those markings mean that D is a midpoint. This means that AD would be a median because it goes from a vertex to the midpoint of the opposite side. Next case, it's not going on the same picture, it's a totally new situation. Okay, so this time I have ABC and AD, and they said that BAD, so follow my pen tip, BAD, that's this angle here, is the same as CAD. That means I have congruent angles, and that means whenever you see angle congruence markings, that's an angle bisector. It's bisecting the angle by cutting it into 2 congruent pieces. Next one. DB is congruent to DC. There we go. And AD is perpendicular to BC. It may not look it, but they're saying there's a right angle here. If you see congruence markings and a right angle, that automatically means a perpendicular bisector, because that's what the name says. It says perpendicular, which means right angle, bisector, which means cut into 2 equal pieces. All right, next one. AD is perpendicular to BC, and that's all we know. Okay, so here's AD. That means I just see a right angle. If that's all I know, it's an altitude. And last but not least, BAD is congruent to CAD. Well, if those 2 triangles are congruent, whoa, I don't like my drawing, sorry. If those 2 triangles are congruent, A, B, C, congruent triangles have congruent parts. So that means this angle and this angle are the same. This angle and this angle are the same. I didn't draw it very well. This angle and this angle are the same, but if we have 2 angles that have to be the same and together they have to be a straight line, that means together they have to be 180. There's only one measure I can have for the 2 to be the same, and they both add up to 180 together. And that's 90 and 90. So this is 90, this is 90, and all the sides that go together would have to be congruent also. All right, so basically what we have on this one is everything else we've already talked about. We have a median because it goes to the midpoint. We have an angle bisector because we have those angle congruence markings. We have a perpendicular bisector because we have a right angle and the midpoint. And we have an altitude because we have a right angle. So the answer for this would be all of the above. Next, the next 2 big problem sections talk about perpendicular bisectors. Remember that perpendicular bisectors meet at a point we call the circumcenter. And the circumcenter is always equidistant from the vertices. In other words, this is the information I'm going to be using on the next 2 problem sets.